Hi all, a grand welcome to Outens Edis Online. Myself Nishad. In this session, we are going to discuss about signal flow graph. We know that a block diagram is a pictorial representation of a system, and a signal flow graph is a graphical representation of the system. Suppose we have a block diagram, then we can directly draw signal flow graph from the block diagram. Now, this is a block diagram representation of a negative feedback closed loop system. Now I am going to draw the equivalent signal flow graph of this figure. So we have R of S is our input and C of S is our output. So we have two nodes. A node is nothing, that is a point which represents a signal or a variable. So for any system, we have two nodes, that is an input node and an output node. Okay. So I am first drawing the input node and an output node. So an input node is a node which have only branches going outside, and an output node is a node which represents some signal or the output signal and having only incoming branches. A branch is an oriented line which connects two nodes. That means suppose this is a node. So this will represent a branch. This is a line segment having a direction. So this is input node. A input node is a node in which there is only outgoing branches. And this is our output node. And output node is a node having only incoming branches. The input node is also called as source and output node is called sink. So input node or source, this represents either output node or sink. Right. We have a branch that connecting between the summing point and this node. I am drawing this branch. We have a take away point at this node, and this is a feedback path having a gain of h of s. So I can draw the feedback path. Now the gain of this node is g of s. So I am writing this as g. And this is a negative feedback. So the gain is minus h of s. So you can write this as minus h. Okay. Branch connecting this node and this node. Suppose the gain of this node is 1. So this point also will represent the output C of s. Okay. So both points will represent C of s. Now we want to find the overall transfer function from this figure. Before that, we have to define some more terms. So we mentioned about node. This is nothing but a point which represents a variable or a signal. And second is a branch, that is a connection between two nodes and have an arrow that will show the direction of signal flow. Suppose we have path that starting from input node and terminating at output node. And in the travel, no node or branch repeat more than once. Such a path is called forward path. In this figure, suppose I am traveling from input node through this path, then I am going towards this node like this. So during this path, no node repeats more than one or no branch repeat more than one. Such a path is called forward path. Okay, suppose I am starting from this point and traveling in this manner through this branch. At this point, I have a path like here and a path like this. Suppose I am moving along this path and again I reach the first node. Already I traveled through this node and again I am going through this node and in this manner. So what happened? I traveled or I crosses this node and this branch twice. So that is not a forward path. Now we have to define a loop. A loop means any path originating and terminating at the same node, then it is called a loop. Suppose I am starting from this node, then traveling along this path. I reach this node and going or moving through this node and again reaching at the first node. Starting and terminating at the same node. That is called a loop. So this is our loop L1. I can mark the forward path as this 1G1. So forward path is indicated by P, notation P, and the branches are this one, then this G and this one. This is a forward path. Now my loop is that is denoted by L. that is starting from this node and moving through this branch. So gain of, so this path G and moving along this branch G dash minus H. This is my loop. Now we have to define gain or transmittance. That is a gain. That may be a complex gain or a real gain of a branch. That is called transmittance. So this branch, the gain is G. So this is the gain of this branch. For this branch, the gain is minus H. So minus H is the transmittance of this branch. For this branch, the gain is 1. The gain is 1. Now we have to define another term that is called loop gain. Loop gain is nothing but is the product of branch gain through a loop. We consider this loop. We have a gain of G on this branch and a gain of minus H on this branch. So loop gain for this loop, that is equal to the product of G and minus H. So that is equal to G into minus H, that is equal to minus GH. Okay, I have a loop like this. This loop is starting from this node and terminating at the same node. And there is no other node. There is only a common node, that is one node. Such a loop is called self loop. Self loop. Suppose the gain of this loop is some G1. The self loop gain, that is equal to G1. That is the self loop gain. Okay. Now, suppose in this figure, I am drawing one more node here. Let the gain of this is G1, this is G2. For this self loop, it be G3. And I am drawing another branch like this, having a gain of G4. Okay, let we have one more node here. Let the gain of this branch is G5 and this is 1. At this point, we get output C of S. Since the gain of this branch is 1, this point also represents C of S. There is one more loop that starting from this node and terminating at this node. Let the gain is minus H2 and gain of this is minus H1. Okay, this will represent some system. Now we want to find the forward path, and we define that a forward path is a path starting from input node and terminating at output node in which no node or branch repeat more than once. Now we can consider the forward path. This path is connecting input and output. So that is a forward path P1. We can represent that by 1, G1, G2, G5 and 1. This is a forward path. Is there any other forward path? Let us check. Now I am moving starting from input node and moving along this direction and reach this node and moving to the output. So in this case also no node or branch repeats. That is also a forward path. So I can write the second forward path P2 is equal to this 1, G4, then G2, G5 and 1. G5 and 1. So we have two forward paths. Is any other forward path? Suppose I am starting from this and moving like this. At this node, suppose I am going like this. So I will again come to the same node. So that is not a forward path. Since this node repeat twice if I move like this. Okay, so that is not a forward path.